Hello everybody! The last couple of lessons we have been discussing the manner in which triangular faces are used to approximate smooth surfaces, and how to adjust the number of flat faces used to approximate the smooth surfaces on various 3D objects. In this lesson, we are going to talk about how to do this with spheres, using an optional second parameter to the sphere command. For an example, I have created a sphere named myObject, I've colored it vanilla, and displayed it. You can see that the sphere has many flat faces on it. If you look a little closer at the sphere here, you can see that these faces are made by the crossing of two types of lines which go around the sphere. If we look from the top down on the sphere, we can see that there are circles of different sizes that wrap around the sphere, with the top of the sphere as their center. The only one of these which has a special name is the one in the center between the poles, which is the circumference of the sphere, called the equator. Then we can also see that there is a set of lines which run vertically from the top of the sphere to the bottom of the sphere. They all meet at the poles of the sphere, or the top and bottom. These lines are called meridians. These lines crossing each other create smaller flat faces which approximate the smooth surface of the sphere. The more of these faces that there are, the higher computational cost the object has, or the more memory and processing time it will take to compute the object. This is an important concept to understand in programming, because no matter what type of programming you're going to be doing, you will be making compromises with computational costs and program performance. By using a second parameter in the sphere command here, you can control the number of each of these types of lines that are used to create the surface, which will control the number of faces used to approximate its smooth surface, and the overall computational cost of the object. The second parameter is a list with two items, which works like the extra parameter in the elbow command does. The first item in the list changes the number of lines that divide the meridians, or run horizontally around the sphere. And the second item in the list changes the number of lines which divide the equator by running vertically around the sphere, or just the actual number of meridians. The default numbers for each of these is 16 divisions of the meridians and 32 equator divisions, or actual meridians. So if we put these numbers in as a second parameter to sphere as a square bracketed, comma separated list, 16 and 32, and then we run our program, then we have exactly the same sphere. We can calculate the number of faces that we have on this sphere with these numbers. Remember that each of these quadrilateral faces that we see on the surface is actually composed of two triangles. So if we want to know exactly how many flat triangular faces are used to approximate the surface of our sphere, then we would multiply 16 by 32, which is the number of these quadrilateral faces, and then multiply that by 2 for the number of triangles in each quadrilateral face, which ends up being 1,024 triangles. Any increase in these numbers will make the sphere much more computationally expensive. To demonstrate the computational cost, let's run our program as is. Now you can see on the bottom left that it took 2.5 seconds to run. If we replace the first number here for the number of meridian divisions to 32, and then we run our program, then it now takes 4.64 seconds to run. This is a considerably larger time for a computer to process something. You can also see, however, that the sphere has a smoother surface. Once again, I'd like to point out that there is more computational cost to make a smoother sphere. Some interesting 3D figures can be made by changing these numbers also. For instance, if we put a 2 as the first item on the list, it will reduce the number of divisions of the meridians to 2 sections. So let's do that and run our program. Wow, this is a very different figure that looks nothing like a sphere. There are 2 divisions of the meridians and still 32 meridians. Let's change the number of meridian divisions back to 32 and the number of equator divisions down to 8. Then let's run our program to see what that makes. As you can see, there are now 8 very distinct meridian lines and 32 meridian divisions, or horizontal lines. So to summarize this lesson, remember that the flat surfaces used to approximate the smooth surface of a sphere are made by the crossing of 2 types of lines on the smooth surface. The lines which go vertically around the sphere, cross both of the poles of the sphere, are called meridians. There's another set of lines which goes around the sphere horizontally, and the largest of these, which goes around the circumference of the sphere halfway between the poles, is called the equator. The sphere command takes a second parameter, which is a 2-item list, which controls the numbers of these lines directly. The first item controls the number of meridian division lines, which run horizontally and divide the meridians. The second item controls the number of equator dividing lines, or the actual number of meridians. By adjusting these, you can make your sphere smoother and create a wide variety of interesting 3D figures. Try adjusting the numbers in the second parameter list and see what kind of figures you can make.